In lesson 12.1, we're going to start talking about trigonometry. Now, have you ever noticed those funny looking buttons on your calculator that say SIN, COS, and TAN? They stand for the words sine, cosine, and tangent. They refer to the relationships of the sides in a right triangle. All the things that we're going to be talking about in this unit are pertaining, I shouldn't even say this unit, with right triangle trig, pertain to right triangles. Look at the triangle below on the left-hand side and see what I mean. Everything that we're going to be talking about is in reference to angle A. So now if I look at angle A as my reference point and I look from the vantage of this angle, I notice that when I talk about it, the definition of the sine of that angle is the opposite side divided by the hypotenuse. So the side that is opposite to the angle A is 3, and the hypotenuse is 5. And so the answer to what is the sine of angle A is 3/5. And we see that here highlighted in red. And you can write it as 3/5, or you can write it as a decimal if you prefer. If I again look at angle A, and I say what is the cosine of angle A? The definition of cosine is the adjacent side divided by the hypotenuse. We really see that there are two sides that form angle A, which I suppose could both be considered adjacent. However, one of them is already defined as the hypotenuse, so the other one is called the adjacent side. In this case, the cosine of angle A then would be 4, which is the adjacent side, divided by 5, which is the hypotenuse. Or, again, you could write it as a decimal 0.8. The final trig ratio that we're going to talk about in this unit is the tangent. The tangent of an angle is defined as the opposite side divided by the adjacent side. So the side opposite to angle A is 3, and the side that's adjacent to angle A is 4. So you would write it as 3/4, or again, you could use a decimal and write down 0.75. Now math teachers, when they talk about trigonometry, like to use something called a mnemonic device. And so if I look at the sign, for example, I notice that the first letter of the word sign is S, and the first letter, and the first letter in opposite is O, and the first letter in hypotenuse is H. So the way that they talk about the sign, to try and remember it, is S-O-H. Likewise, for cosine, they use C, A, and H, which stand for cosine is adjacent and over hypotenuse. And for tangent, they use T, O, A. And what you'll hear most math teachers talk about going forward with trigonometry is the phrase SOHCAHTOA, which represents these different letter groups in a sound tool. That's why it's called a mnemonic device, SOHCAHTOA. Here's another example of trig ratios. Again, remembering that when we're talking about this, we're talking about everything in reference to angle A. So when I look at angle A and I talk about the sine of angle A, we switched, pardon me. I noticed here that we're now talking about angle B. So now we have to switch our reference. So now here's angle B highlighted. And now, as I look from angle B to the sides, I have to change the way I'm thinking about what is opposite, adjacent, and hypotenuse. So as I look from the point angle B there, I know that the side that's opposite to angle B is this side right here, opposite to angle B. And that means that when I look for the sine, I'm going to have 24 as my opposite side. The hypotenuse doesn't change, it's the longest side in this right triangle. and it happens to be 25. So the answer to what is the sine of angle B is it's the opposite over the hypotenuse, or in other words, 24 over 25. Likewise, as I look at angle B again, the adjacent side is going to be 7, and the hypotenuse never changes, it's 25. And so I take 7 over 25, or in other words, 0.28. And finally, in this grouping, if I look at angle B and I say, what's the tangent? That's my opposite side, which we learned earlier was 24, over my adjacent side, which is 7. So 24 divided by 7, or 3.429. This was showing us how we can choose a different angle as our angle that we're going to be starting with. So in the previous slide, it was angle A, and in this side, it's angle B. Now we're going to use our knowledge of trig ratios to find some things. So the first thing that we're going to do is we're going to talk about how to find a third side. So a third side, we don't really have to use trigonometry. We use the Pythagorean theorem. If I look at my first triangle, I see 3 and 4, and I want to find the final side. This is where, when we're finding the third side given two sides, we use that famous Pythagorean theorem, a squared plus b squared equals c squared, or I told you leg squared plus leg squared equals hypotenuse squared. So in the triangle that's on the top left, I would have 3 squared plus 4 squared equals c squared. So that's 9 plus 16 equals c squared. Or in other words, 25 equals c squared. But I don't want c squared. I want c. So I have to square root both sides. And I find out that my c then ends up being 5. So this is the hypotenuse side. In the triangle down below, however, they give us the hypotenuse. So in this case, if I'm looking for the sides, let's say I call the little side side A, for example, then I would have a squared plus 24 squared equals 25 squared. Or in other words, a squared plus 576 equals 625. Now to find my a squared to start with, I would have to subtract off 576 from both sides, which then would lead me to understand that my a squared would have to be equal to 49. And just like in the previous example, I'm not allowed to have a squared, I'm just looking for the side length a, so I would square root both sides. And when I square root both sides, what that means is that my a is the square root of 49, or in other words, my a would be 7. And these two examples are showing when you're looking for a hypotenuse, you're squaring and adding, but when you're looking for a leg, you are squaring and subtracting. That's kind of the big idea on this slide. In our next slide, we're going to start getting into the using of trigonometry itself. So we're going to be given one side and one angle, and then try to find a side. And what you need to do is you need to think about what's being given and what's being asked for. So let's say I'm looking for side BC, this side right here with the X. And what I know is that I am going to use trigonometry to understand this. So I see that I'm given an angle of 30 degrees. Let me highlight instead of underline, sorry. I'm given this angle of 30 degrees. I'm also given the side that's adjacent to it, but I'm looking for the side that's opposite to it. So I have an angle involved, I have the opposite side involved, I have the adjacent side involved, and when you're talking about an angle with an opposite and adjacent, this is the word tangent. So when I set up an equation to try and solve this, what I would say is that the tangent of 30 degrees is equal to the opposite side divided by the adjacent side. Now in trigonometry, the first thing that you have to make sure of is that you're in the correct mode. And so in our class, when you do this, you want to make sure that your mode is in degrees, because our angles are going to be given in degrees. So go into your mode button, change the degrees if you're not already in there, and make sure that you're in degrees. Now when you look at the tangent of 30, if you type the tangent of 30 into your calculator, what you find out is that the tangent of 30 is 0.5773. So tangent 30 that we see right here, when you type it in your calculator, out should pop 0.5773. Check that out now. The big deal with trigonometry is you are always going to be writing trig to 4 decimal places. This is required. You have to have 4 decimals. That's why I went 0.5773 instead of just 0.58. Otherwise, you will not be accurate enough in your degree measurement. Now these 0.5773 decimal that represents the tangent of 30 is still equal to my x divided by 10. And to undo the division by 10, of course, I would have to multiply both sides of this equation by 10. So I multiply the right side of the equation by 10, I multiply the left side of the equation by 10, and I find out that my side that I called x, which is also known as BC, would be equal to 5.773. And the big idea in this slide and in following slides is we're going to be given 2 pieces of information, finding a third, and based on the angle and the 2 sides that are involved, whether they're given as a knowledgeable number or a find a number, will tell you which trig function to use. So remember, when we talk about opposite and hypotenuse, that's sine. And when we talk about adjacent and hypotenuse, that's cosine. When we talk about opposite and adjacent, that's tangent. Let's try another one.